Welcome to the Globe Educator 1 Week Pacing Guide series, and tonight we'll be talking about urban heat islands, or as some people are starting to refer to it, extreme heat. So I'm Angie Rizzi, but I'm going to pass it over to Jessica to introduce herself.
Thanks, Angie. I am Jessica Taylor. I am a physical scientist at NASA Langley Research Center, and I have been involved with the GLOBE program for a really long time. I was a student at Florida State University, and my major professor introduced me to GLOBE, and I went outside every day to collect measurements, and I really feel like being part of the program and learning how to do science through the program helped me see myself as a scientist. And so it wasn't until years later that I got the opportunity to join NASA as a physical scientist, and I am really excited to be able to continue participating in the program from my new position. So I'll go ahead and pass it back over to Angie.
Thank you, Jessica. So again, I'm Angie Rizzi. I work with Jessica at NASA Langley Research Center. I was not a GLOBE student, but I used GLOBE with my students. I taught middle school science for about a dozen years, and I also taught high school earth science and math as well. And in the last several years in the classroom, I implemented GLOBE, and it was so effective with my students in broadening their skills in so many areas that I just became a huge fan and supporter. And when I had the opportunity to join the team, I jumped at it because I love getting the message out about GLOBE. I also work on the MyNASA data project, and you will see some of those resources referenced this evening as well. So I like to start off with some kind of something that people can enter in the chat. And I can't see the chat right now because I'm presenting, but these are two pictures that were taken from different GLOBE observations. And I was wondering if you can add in the chat what differences you see in these images. Cement, oh, I do see it now. Cement in one, not in the other. Thank you, Donna. Buildings in one. Vehicles. Okay. And so if we have buildings in one, but not the other, oh, a few clouds in one. I love that. The sky seems bluer in the right image. Oh, very observant. That's great. So we can see that there are differences, and we'll refer back to this as we progress through. As we've been doing in all of these pacing guide webinars, we will be talking about the elements of the guide, then we'll talk about the actual 5-day sequence for Urban Heat Island. We'll give you some time to go out and play around with one of the activities, and then we'll just talk about implementing it. And Dr. Kevin Sykowski, who has graciously joined us tonight, will share some things at the end about how we can take it further. So the elements of the pacing guides are that they all have at least one type of GLOBE observation that can be done, typically using the GLOBE Observer app from the GLOBE program. But there's also some kind of hands-on activity and a MyNASA data activity. This pacing guide in particular gives them the opportunity to collect measurements using an instrument or an infrared thermometer. So that's one thing that's really nice about this particular pacing guide. And then there are basic sections. I'm going to go through those sections now. So every pacing guide has this overview section, and this section has several different aspects. One is the phenomena. Ooh, look at this. I see an error here. This should say Urban Heat Island. I will fix that soon. So there's a phenomenon, there's a grade level, 6 through 12. For this particular pacing guide, some of them include some elementary grades and some of them do not. There will be a guiding question in this guide. It is, what environmental conditions influence surface temperature? There's someone that you can reach out to if you have questions, and tonight's special guest, Dr. Sikowski, is that person. And then there are some aspects here for taking it further. So if you like Globe and you want to become a Globe trained teacher, you can do the training. There's e-training available as well as workshops. If you want to do further investigation, Dr. Sikowski will talk about that later. And then there's accessing all the guides. So if someone shared this link with you and you want to go and see where all of the guides are, you can look there. Each guide has a standards alignment. It is aligned such that the guides support these. They do not necessarily completely fulfill all of the 3D aspects of NGSS or the entire performance expectation, but they do support these. And this is just a snippet. There are high school standards for this one as well. And each pacing guide has background information. And I'm going to pass it over to Jessica to talk about the background information.
Great, thanks so much, Angie. I think you can see in this graph here that when we're talking about urban heat islands, what we're talking about are the increased temperatures that you often find in urban settings. And if you look closely at this graph, it is a graph of temperature, even though it's very pretty and graphical here. But this line here is showing you temperatures, and there's Celsius on the left, Fahrenheit on the right. And you can see that on the outer edges, we are looking at locations that are identified as rural, so rural forest or rural farms. And as you're getting closer into the city, you start to have a suburban landscape. And then within the city, that would be categorized as urban landscape. And you can see that the temperatures have this dramatic difference oftentimes in these urban heat islands. So we're going to go ahead and go to the next slide and hear a little bit more about urban heat islands from one of our NASA projects.
Did you know that over 50% of people live on islands? Well, these aren't your typical islands. Over half of the world's population lives on urban heat islands, or places where our buildings, roads, and car parks trap more heat than the surrounding rural area. Satellites measure Earth's land surface temperatures, which vary with the sky, the wind, the land surface, its albedo, and of course, the season, due to the sun's angle. Yellow shows the warmest land, while the coolest land is blue or white. Land in the tropics is always warm, while land in the northern hemisphere is warmest from June through August, and the southern hemisphere is warmest between December and February. But scientists also observe hotter temperatures in cities compared to rural areas. Increasing urbanization, or human development of natural areas, can be seen from space by our lights at night. City structures and surfaces like buildings and roads absorb more of the sun's energy during the day and emit that heat back into the air at night, making cities warmer than the surrounding countryside. This map of summertime temperature differences between urban and rural areas shows the urban heat island effect. Paving over natural landscapes removes the cooling effect that plants have through evaporation and water retention. Pavement makes cities hotter. Plants make cities cooler. Some notable heat islands occur in Manhattan, where nearly the entire landscape has been turned into urban area, and London, where the urban heat island effect was discovered in the 1800s. Urban heat islands have been linked to human health issues like heat stress. With nearly 2/3 of humans living in cities by 2050, we'll have to start thinking about how to sustainably develop our cities to avoid heat island effects by using things like reflective and vegetated roofs and more pervious surfaces and planting urban trees. For more information, visit climatebits.org.
Great. Thank you, Angie. Hopefully that
Did
gives
you
you a
know that over
good,
50% of
solid
people live on
introduction to this idea of urban heat islands. Thank you. So on the next slide here, something that
Did you
I thought
know
was
that over
really
50%
interesting.
of people
There we go. I had not necessarily realized this before, but extreme heat causes more deaths than any other weather-related hazard. And thousands of people who are exposed to extreme heat also wind up seeking medical attention. And so, of course, many of those do not die. But if you even just think about the number of people that wind up needing medical attention because of this extreme heat, there are over 65,000 Americans that every summer need to seek this medical attention. And unfortunately, we do have so many related deaths to extreme heat. This is one of the reasons why this topic in particular is really important. Let's go ahead to the next slide. And I think it's important for us to consider and just remember that extreme heat is something that can affect everyone. But there are factors in particular that put some people at risk more than others. And when we're thinking about these factors, these are kind of high level factors. So the first one is exposure. So this has to do with maybe where do you work? In other words, do you spend a lot of hours outside working or exercising? This could also include those who are homeless, as well as people who live in buildings that don't have air conditioning. The second one is sensitivity, right? So some people will be less tolerant to heat than others, and that could be individuals like infants, young children, pregnant women, older adults, and people who have certain medical conditions. And people can be more sensitive to heat in particular. And so it's really important for us to protect those populations. And the third risk factor in particular has to do with this ability to respond or to prepare. So some people are less able than others to avoid heat, or those with limited incomes may not be able to afford the air conditioning or certain types of electricity. And others, such as people with mobility issues, might not be able to get away from some of these heat events. And so when we start thinking about extreme heat, it can be a little bit based off your location, what your daily activities are, and then who you are. Now, the image here on the right might be a little bit difficult to see in the presentation, but it really showcases specific locations and individuals who may be most at risk. And in particular, in the far left, we see that folks in urban areas in particular, because of the reasons that the video shared, these locations in particular wind up kind of generating a lot of extra heat. And then people in these areas are less able to escape that heat. So these are some of the things we think about when we think about extreme heat, and it is intricately linked to urban heat islands as well. Go ahead to the next slide. So when we think about urban heat islands here on the ground, we can start trying to think about, well, what is NASA's role and how can we use satellite data in particular to help us better understand urban heat islands? So this is an example of a location from space. So this is Providence, Rhode Island, and this is using different instruments on board satellites that are in space looking back at Earth. So on the far left, we have a visible image. In other words, basically a camera taking an image of the location. The second image in is showcasing surface heat. And so you can see some of these pops of colors. And here, what we're seeing is the lighter color, kind of that yellowish color, are warmer areas, and the purples are cooler areas. The third image here is showing us what land is developed. And so in that video, we begin to start really thinking about how developed land looks very different in terms of what its surface temperature is compared to an area that is covered by natural grasses, plants, forest, etc. And on the far right, another indication of that going back to the vegetation coverage. So you can begin to see how we might use lots of different information from satellites to better understand urban heat islands. Next slide. And I mentioned that we use a number of different instruments, and this is a graphical representation of the many satellites that NASA has specifically monitoring Earth. So this is the Earth fleet. So I know we oftentimes think of NASA, and rightfully so, as exploration of our solar system and our universe, but NASA is also responsible for monitoring the health and welfare of our own home planet. And so it takes a number of satellites and a number of different types of instruments, like what we talked about, to be able to use visible cameras, infrared, and other types of technologies, and help us combine all of that together to better understand what's happening on Earth. Next slide. So that was satellites, but NASA also uses a number of other platforms to help better understand what's going on with our home planet. We certainly have those satellites in space, but we use other types of put instruments on other types of platforms, including things like CubeSats. We launch different balloons. Something that NASA Langley is very involved with is oftentimes airborne instruments. So we put instruments on board aircraft and fly them into locations that are specifically interesting to us, so that way we can check sometimes to make sure that our satellites are working correctly, or we might do instrumentation checks as well, or maybe we need to fill in some of the gaps of our data. And then if you look closer towards the ground, we do use ground-based sensors, radar, but the one in particular I want to mention here are smartphones, citizen science. And this is where the GLOBE program helps to complement the many different types of data we have to help us better understand our planet. Next slide. One of the reasons we do that is because our vantage point is different. It's the same reason that we use lots of different types of instruments on board satellites in space, and we put different instruments in different locations of the atmosphere and on different parts of our land. It's because all of these tell us a little bit more information. Your perspective on the ground looks very different than that of a satellite looking back down at Earth. And this is maybe obvious for, say, clouds, for example, because for clouds, we see the bottom when we're on the ground looking up, and satellites see the tops of the clouds. But the same is true in some ways for land cover, in that we are experiencing it from a very different vantage point, and we can touch it. We can see exactly what is happening at our land cover site, and the satellites sometimes need that extra information to help fill in the gaps. And so that's one thing that you'll be able to do through GLOBE when you make your land cover observation, is you'll actually be able to compare your observation to the latest information we have from satellites. So go ahead to the next slide. So I'm going to go ahead and pass it back to Angie to start us going through the days of activities related to urban heat island investigation.
Thank you, Jessica. So we typically share these slides. This slide is a placeholder in here for you to know where you can quickly link out to our partner page and find all of the guides, as well as the link for the specific urban heat island guide. And I'm going to go through the 5-day sequence of activities. So on the first day, you get to watch the video that you just watched, that Jessica talked about, the Climate Bits video. And then there is a quick MyNASA data activity where you analyze graphs of surface temperature throughout the day. So this graphic looks very similar to the one that Jessica already discussed, but it has day and night time. And it has surface temperature and air temperature. So surface temperature really meaning that on the ground, and the air temperature being several feet above the ground. And so you can see the differences between night and day. There's something of particular interest here over the pond. And then you can compare your rural, suburban, and increasingly urban areas for day and night, as well as the ground and the air. Each day, we have a connection back to the guiding question. So that remember that guiding question from the overview. So on day 1, the connection back is, why do you think the air and surface temperatures are higher in the cities? So the students can say what they think. Oops, sorry, a little too heavy on the mouse. On the second day is a mini urban heat island investigation, and this is where they get to make observations and use an instrument. They will use an infrared thermometer. Now, the way that this activity is written, it is written to get the surface temperature of various surfaces in the sunlight, and then to do it an hour after sunset and find the difference. We realize that that may not always be practical in a classroom setting, so this is easily modified that you can just compare the different surfaces if you want, or you can do some of these surfaces maybe in the sunlight versus in the shade. So there are some different ways that you can modify this, and the connection back to the guiding question is, which surface materials would make your area cooler? And you can also modify that question if you would like. So this is an image here of an infrared thermometer, and we just wanted to make a couple of points about using one. Typically, there's a digital display, which is what you're seeing here. Oftentimes, you can measure in both Celsius or Fahrenheit. There's a recording button. We recommend that you call it a button. There's the line of sight and the sensing eye. And then this is just for accessing your battery. Now, oftentimes, the sensors for the line of sight will have like a laser pointer. It is important to remember, if you're using this with students, that you instruct them never to point it into anyone's eyes. And a lot of teachers cover that with tape because the laser pointer is only showing you where you're pointing it. It is not having any function of making the measurement. And as you note here in the picture, you want to extend your arm out. And do you see how the sensing eye is parallel to the ground? So you don't want to measure your shadow or your own foot. You want to measure the surface that you're trying to measure. Jessica, did I leave anything out on that?
No, I think that was great. I just want to add that an infrared thermometer is oftentimes pretty cheap, and something that we have seen really widely available throughout this pandemic now. It's become a more popular instrument. But if you were going to invest in an instrument for your students, this is probably one of my favorite instruments to invest in. You can purchase them for as little or fewer than $20 each. And it's such it's an immediate measurement, right? So you can immediately compare this surface to that surface. Like you said, Angie, in the sunlight, in the shade for the same surface type. And it really allows students to come up with their own inquiry questions.
And I'm glad you said that, though, about it becoming so common, because there are some differences between those that we use simply to take a human's temperature versus the ones that we would use for this activity are going to have a wider range where they can measure really cold and very hot temperatures as well. Then on day 3, we have another MyNASA data activity called Patterns in Earth's Surface Temperature. And this is, they're going to say, where do you think the most developed land is located? But I'm going to link out to this and show this to you. So on MyNASA data, it will look like this, and you'll have an overview and some teacher information and your learning objectives, etc. But if you click on this very prominent blue button, you will go out to a little GIS activity. And I just want you to see that we do show the performance expectations that are supported. And the first one that loads is going to be some land surface or skin temperature in Austin, Texas. Okay, so they can zoom in, they can zoom out, and they can just investigate the land surface temperature. Okay, sorry, I'm not trying to make you queasy there. And they have a question or two. And then we go to the next part, and this is comparing the land cover and the land surface temperature. So it's a slider. Oh, okay. I think that's my internet connection. I apologize for that. I just tested it earlier. So we have the land cover and the surface temperature, and they can begin to make some connections. Then we have the surface temperature of cities. Okay, let me try reopening the whole thing. Or we were already planning to let you go out and explore this yourselves. So we may just give you your...
Angie, I've gone ahead and added the link to this, direct link to the GIS Interactive is in the chat now.
Great. So the one thing I just wanted to show you is that when we get down to this last part, well, it's not the last part, but the surface temperature of cities, I did want to explain that these circles are the air temperature a few feet above the ground. But that link that she put in the chat is we were planning to give you about 5 to 8 minutes to go out and explore this. So if you could please take a few minutes to go look at it, and then maybe just put a little comment in the chat when you are sort of back. If it's more than 8 minutes, I'll go ahead and continue the presentation. If you have any questions, please put them in the chat. So we have someone whose computer isn't working with this, so I will continue. We saw here that we had the different land cover classifications and the surface temperature, so they can begin to make some associations there. They will answer questions. I'll leave them up for a minute so you can look at them. Then we move on and we have still the same land cover classification and surface temperature, but then we've added air temperatures in some specific locations. So you can see this, and the visualization part there is just adding the circles. But what I really like about this is that there's a table that they fill in. So they have to slow down enough to really interpret what they're looking at. And they put in the surface air temperature, the surface skin temperature, and the land cover type for each of the locations with the circles. And so I really like that it forces them to take a deep dive and really interpret what they're looking at. And then they can use those data to answer the questions going on. And then it starts to take a look at developed land. And on this part, there's a little bar at the bottom. And if you click on that, you can hit play and you can see how the developed land has changed in Austin over time. And so based on that, they can look at 4 quadrants and look at how it's changed and how they think surface temperatures in Austin have changed. And then we just have some links to some related content. So I see a question in the chat about being able to do this for areas beyond Austin where the students might live. And that is on our to-do list, but currently this will only show Austin. And then Jessica put another activity in the chat that may be just as helpful. Okay, I'm going to go ahead and move on to day 4. Day 4 is when we have the chance to make our actual globe observation. And it is, for those of you who are very familiar with GLOBE, you'll notice that this is not the GLOBE surface temperature protocol. This is actually using, you can do land cover and or tree height. You can imagine that tree height could have an impact on surface temperature, but we chose to really highlight land cover this evening. And the reason that we have that associated with it is for those people who are not as familiar with GLOBE, using the GLOBE program's Globe Observer app can be a little more accessible. And so we wanted to make this as accessible as possible. And so this question will be, how might land cover affect the surface temperatures? And I'm going to share another video, a quick video on how to do the land cover observation. I saw a question in the chat about, yes, thank you, Jessica, for answering that question. And I see another comment. Their class drew a map of their campus and colored it based on examples given by GLOBE and MyNASA data. Plus the art teacher loved the use of the cool and warm colors. That's great. So after they make their land cover observation, we come back, and on day 5, we have this microclimates activity. And it's similar to what they do in the beginning when they measure the different types of surfaces. But this is one where, related to what Lisa said, they have the opportunity to draw a picture of their site. They pick 2 different locations. They predict, they indicate if they're using air temperature or surface temperature, and they're going to predict what they think the differences might be. And again, they get to practice using an instrument and making a measurement. So this is a really fun activity. And this connection back to the guiding question is, what evidence did you find to support the urban heat island effect? And if you didn't find any, why not? So this is fun, and there's a good summary, and we give the option to do the infrared thermometer or just a regular thermometer in this activity. So connecting all of this to NASA, you may know the background information, but what about the students or the learners? How and why does NASA study urban heat islands? And NASA uses satellites, this would be the how, to observe the land cover, the vegetation, the surface temperatures, and it's studied because the effects can be dangerous, especially in the summer. And there are ways to lessen the effects. So that would include changing surfaces, introducing more vegetation, including plants and trees. And that's why the tree height measurement is an option on day 4 if land cover might take you too long. So there are additional resources with each pacing guide, and these resources are designed to help you swap out if you want to help you make it your own. If one of the activities doesn't quite work for you, you can extend it. It can also help you maybe customize it a little bit more to the grade that you're working on. In particular, I want you to see this activity, analyzing surface temperature differences. I'm going to link out to this. If you don't have the infrared thermometer or you don't have the ability to go outside and make measurements, this activity does have a labeled picture of different surfaces in shade and not in shade, so that that can be explored on one of those days of making the measurements, even if you don't have the ability to go out and do that. So that's there. I'm just highlighting that one, but there are lots of additional resources. So if you guys would like, I would appreciate it if you could put one thing in the chat of how this pacing guide might help you implement GLOBE. And I see names that I know in this who I know will have excellent feedback for us. So we mapped our campus, green areas, windy areas in the fall, and collected data while creating a phenology garden. The wind is for wind turbines, which relates to renewable resources. I love this activity. We do it every year. That's great. One of the things that I really like about this topic is that you can do it as simply as exploring the different surfaces and their impact, but you can take it really far. You can take it into deeper research, a project, a community action, exercises for training pre-teachers in hybrid classroom formats. That's a great point. And taking temperatures of different surfaces can engage students in thinking about research questions. Absolutely. Renewable energy. I like how the GIS Interactive was presented so the students could explore before doing the land cover observation. Thank you for that. The structure and content for where to start. Great. Because what we tried to do is do some of the planning for you and make some of the difficult choices. We made the difficult choices to narrow it down to 5 activities, but as you can see from our list of additional resources, it could have been formatted differently. We do have assessment options built in, so those connections back to the guiding questions, and then each activity has its own formative assessment options. If you follow through and you use those connecting questions, you can help them build a story, and we're trying really hard to keep it flexible for you. A lot of kids like to take temperatures of different colored cars. That is true, and that is cool. It's a good way to get them collecting data from more natural surfaces. Thank you for that. So I'm going to pass it off to Dr. Sykowski now, who's going to talk about how you could go take it further beyond this pacing guide.
Well, thanks, Angie and Jessica. Both of you did a great job, and I really appreciate the resources that you presented. So if we could take a look at some of the slides here. So I wanted to mention getting involved with GLOBE itself. I think that might be, see what's next. There you go, okay. Yeah, this is part of a talk that I give with Janet on Urban Heat Island. Let's go to the next slide. And GLOBE, I looked it up today. Now we're in 126 countries around the world, and many, many schools and teachers are involved. So if you haven't gotten involved with GLOBE yet, this is a great opportunity. I think it's a great way to engage students in system science. You can take observations and then see their observations on the internet pretty much right away. So let's go to the next slide. And I just put a few slides together. I circled the Get Started button on the globe.gov website. And there you can then sign up as a teacher. And I think that's the next slide. Yeah, so click on Teachers and Educators, use your own email address, and you can sign up to be a GLOBE person. But you do have to do some training. And so I believe the next slide, we talk about the e-training slides. And so you go under Get Trained, and then there's a protocol e-training. And it's just a good way to do it on your own. And it doesn't take a lot of time. So we go to the next slide. The guidelines to become a GLOBE teacher. You must do the Introduction to GLOBE module, and then you can pick one of the spheres. So in this case, I picked atmosphere. There's also hydrosphere, biosphere, and pedosphere. And then you have to do one protocol module. So surface temperature is the one I like, and I really like using the infrared thermometers myself. So let's go to the next slide. And then once you do that, you do have to take a quiz for each of the modules, get 80% or better, and then you will be a GLOBE teacher. We have our GLOBE Urban Heat Island student research. Now it's called an intensive observation period instead of a campaign, but we really focus on October, December, and March as our observation. So right now is one of our months for doing the surface temperature for Urban Heat Island. And we use air temperature and clouds, just like Jessica said, and she said as well. You can look at all those observations. So let's go to the next slide. Now, why do we use surface temperature? And of course, that's something that satellites observe. And I did want to talk about this for just a second, because this is the science behind using surface temperature to study the Urban Heat Island. The surface temperature is at the heart of the energy budget. The sun heats the ground. Any of the energy that comes through the atmosphere, it can heat the ground. But some of that energy can go into evapotranspiration, and that cools the surface. so water evaporating from the surface or plants transpiring water. Some energy goes into sensible heat, and that's the heat we feel, the temperature of the air. And then some of the energy goes into long wave radiation or is emitted back towards space. But also greenhouse gases and clouds do absorb some of that energy, and that's what keeps the Earth warm. And of course, with increases in greenhouse gases, that's the energy that's being absorbed by those extra greenhouse gases and warming the Earth. So that's, the surface temperature is right at the heart of everything. So if we go to the next slide. And Angie already showed how to take observations, so maybe we could skip through that. And so Angie, there's my son Timmy taking the picture of image of the temperature of his shadow. Now, this is important. When you do an observation for GLOBE, you want to take 9 observations within a homogeneous area. So in this case, this is the softball field. This would be a grass site. The site itself has the latitude and longitude assigned to the center of the site. And then the students would take 9 observations randomly within that area, but all of those observations should be of grass. All right, and then the next slide shows you, the 9 observations, good. And then the next slide, and that's not what to do. Don't take 3 of the gravel on the softball field and then the other 6 on the grass. And this is from the e-training module. All right, so we can go to the next slide. And I just wanted to show some of the data. Now this is as of 2020, September. I suppose we could update this, or I could update it. But it shows who's taken surface temperature around the world. And you see there's a really good distribution. We have these intensive observation periods because we want as many schools as possible and as many students as possible to take observations on the same days. And having more observations makes for better research projects, because then a student can compare their observations to data taken in another school. It could be another country, it could be urban versus rural, the nearby school. So there's great opportunities around the Great Lakes. It could be city or schools near the lake and those further away from the lake to see how the water affects the temperature. All right, and then next slide. And actually, I wanted to mention that this is part of a project called GLOBE Mission Earth that's funded by NASA. And Angie and Jessica also work on that project with me. All right, well, thank you, Angie, for going through those. As students, as you get into GLOBE, we hope you have your students do research projects. This pacing guide gives you activities that help you along that way. So observing the different temperatures outside of grass or asphalt, that can turn into a research project for the students. We hope that they enter their data on the GLOBE website and then can use that data to ask a research question. And it could be as simple as, how is the grass, how does the grass have a different temperature than the asphalt? And that's interesting for the students. And some students have also looked at their playgrounds and the playground equipment. So a lot of different research questions they can ask. All right, well, thanks, Angie.
Thank you, Kevin. So at this time, we'll open it up if anybody has any questions that they want to enter into the chat. I'll stop sharing so you can see our faces. Oh, thank you, Janet, for that. There is a Google Classroom that you can join. If you contact Janet Struble, she put her email in the chat. And Jessica just shared the link for the slides. Thank you.
Yeah, that should be the view link. And if you want, you can then from there make your own copy to then use if you want to use them for your classroom, or if you can just keep it as view only if you plan to just kind of use it for your own references. So Hopefully this was interesting and helpful to you, and you get some idea of kind of the distribution, right? This continuum is however much you want it to be. You can start out small by picking even a couple of the activities, implement the full pacing guide, or also then if you get really interested, because this topic is so relevant, maybe consider joining the Urban Heat Island Surface Temperature Intensive Observation Period that Dr. C shared, because it is just a topic that we have found that most students really gravitate towards.
Thank you. And we see in the chat here also that a number of the teachers have applied for and received grants to purchase surface temperature or other globe equipment from an organization called YLACES, and that link is also in the chat. Well, thank you everyone for your time. We'll hang on for a few more minutes if there are any questions, but we appreciate you coming out tonight.
Thanks, everyone. And if you do have any questions for us, feel free to put them in the chat. And like Angie said, we'll hang out for a little bit. Take care.
Bye-bye.